Welcome to my channel Detailed Math Solutions. In this video I'm going to show how to find the four special products with three-factor decimal higher degree terms displayed on the screen. To solve these exercises I'm going to use the special product formula for sum and difference of the same terms, a plus b in parentheses multiplied by a minus b in parentheses equals to a squared minus b squared. This formula can also be written as a minus b in parentheses multiplied by a plus b in parentheses equals to a squared minus b squared. I'm going to use the formula written in both ways to solve the following exercises. In the first exercise, I need to switch the places of the two terms within the first parentheses. This way I'll be able to use the formula. When I do that, this can be written as 1.4 a to the fourth power x to the third power plus 0.4 a squared x in parentheses multiplied by 1.4 a to the fourth power x to the third power minus 0.4 a squared x in parentheses. The first term, 1.4 a to the fourth power x to the third power, will correspond to the a in the formula. And the second term, 0.4 a squared x, will correspond to the b in the formula. And when I use the formula, this will equal to 1.4 a to the fourth power x to the third power in parentheses squared minus 0.4 a squared x in parentheses squared. When I distribute the exponent, I have 1.4 squared a to the fourth power in parentheses squared x to the third power in parentheses squared minus 0.4 squared a squared in parentheses squared x squared. When I simplify further, this equals to 1.96 a to the 8th power x to the 6th power minus 0.16 a to the 4th power x squared. In the next exercise, I need to do a similar thing like the prior exercise. I need to switch the places of the two terms within the second parenthesis. When I do that, this can be written as minus 0.6 a to the 6th power x to the 5th power minus 1.6 a to the 8th power x to the 7th power in parentheses multiplied by minus 0.6 a to the 6th power x to the 5th power plus 1.6 a to the 8th power x to the 7th power. This way, the first term minus 0.6 a to the 6th power x to the 5th power will correspond to the a in the formula. And the second term, 1.6 a to the 8th power x to the 7th power, will correspond to the b in the formula. And when I apply the formula, this equals to minus 0.6 a to the 6th power x to the 5th power in parentheses squared minus 1.6 a to the 8th power x to the 7th power in parentheses squared. This simplifies to minus 0.6 in parentheses squared a to the 6th power in parentheses squared x to the 5th power in parentheses squared minus 1.6 squared a to the 8th power in parentheses squared x to the 7th power in parentheses squared. This equals to 0.36 a to the 12th power x to the 10th power minus 2.56 a to the 16th power x to the 14th power. In the next exercise, I need to do a similar thing, but this time I need to switch the places of the two terms within the first parenthesis, and also I need to switch the places of the two terms within the second parenthesis. This way, this will equal to 1.7. A to the power of 0 is 1, and multiplied by 1.7, it gives 1.7. Therefore, I'm just not going to write that. And then I have x squared plus 0.7 a to the 9th power x to the 3rd power, in parentheses, multiplied by 1.7 x squared minus 0.7 a to the 9th power x to the 3rd power. This way, the first term 1.7x squared will correspond to the a in the formula, and the second term 0.7 a to the 9th power x to the 3rd power will correspond to the b in the formula. And when I apply the formula, this equals to 1.7 x squared in parentheses squared minus 0.7 a to the 9th power x to the 3rd power in parentheses squared. When I distribute the exponent, I have 1.7 squared x squared in parentheses squared minus 0.7 squared a to the 9th power in parentheses squared x to the 3rd power in parentheses squared. This equals to 2.89 x to the 4th power minus 0.49 a to the 18th power x to the 6th power. Similar to this exercise, I'm going to switch the places of the two terms within each parenthesis for the next exercise and write it as minus 0.8 a to the 10th power x to the 6th power minus 1.8 a to the 4th power x in parentheses multiplied by minus 0.8 a to the 10th power x to the 6th power plus 1.8 a to the 4th power x. This way, minus 0.8 a to the 10th power x to the 6th power will correspond to the a in the formula, and 1.8 a to the 4th power x will correspond to the b in the formula. Therefore, this will equal to minus 0.8 a to the 10th power x to the 6th power in parentheses squared minus 1.8 a to the 4th power x in parentheses squared. This equals to minus 0.8 in parentheses squared a to the 10th power in parentheses squared x to the 6th power in parentheses squared minus 1.8 squared a to the 4th power in parentheses squared x squared. This expression simplifies to 0.64 a to the 20th power x to the 12th power minus 3.24 a to the 8th power x squared. Thank you for watching. If you liked this video, please subscribe to my channel and click the like button. I'm thrilled that you joined me and look forward to sharing my other videos. Please click on any video displayed on the screen to see more detailed math solutions.